This is Module 3.1, Flight Preparations. This module describes the procedures for preparing a radiosonde for a flight. Nothing in these procedures needs to be memorized. Everything is written down in printed checklists, and the checklists go into more detail where necessary. Should any problems occur, you'll have ample time to consult written manuals and procedures to find out what needs to be done. So sit back and just try to get a feel for what's involved in flight preparations. The pre-release flight schedule starts about 60 minutes before release. In this module, we'll focus only on the sonde preparation. Balloon inflation will be covered separately. The first step in flight preparation is to unpack the sonde and do a visual inspection. Open the foil bag and remove the contents, being careful not to damage the sensor boom. Visually inspect the sonde to confirm that there is no damage. Confirm the temperature sensor is intact and doesn't have any nicks or discolorations. Confirm the 4 prongs to the humidity sensor are clean and intact. Confirm the GPS antenna is intact. Confirm the radio antenna is intact. If all that looks good, then we're good to go. If there are any obvious problems with the sonde, then put the sonde aside and get a new one. Pull the release latch to open the test set chamber. Carefully place the sonde onto the tray, then gently close the lid. Connect the cable to the sonde with the up label on the connector facing upwards. Then turn the GC25 power on. The GC25 will now be controlled from the computer, so connecting the sonde and turning the GC25 on is all that's needed here. Also, turn on the computer and the MW31 sounding processor. You would normally go fill your balloon now. The balloon inflation takes place from minute 30 to about minute 50. This topic is discussed separately. Once the computer has finished starting up, look on the computer desktop and click on the 2 icons to start the communication software. WinFile scans the message directory every minute and moves any data messages into the outgoing messages folder. WinXPPP scans the outgoing messages folder every minute and transmits any messages to the regional weather center. Now click on the Digicora icon to start the Vaisala sounding software. Select New Sounding. Now you'll work through a sequence of status and information screens. It may seem like a complex maze of screens and controls, but in reality the software is doing most of the work for you. On the left you can see the sequence of screens that will be displayed, and will notice that there's normally very little input required other than clicking Next. So on a normal flight there's really only 2 places for operator input. If the GC25 test set is connected to the sonde and powered on, the sounding workbench will automatically start communicating with the sonde. Click Next. The software shows the radiosonde properties, and you can specify the type of wind calculations. Normally, these default values are fine and no changes are needed. Click Next. The Edit Properties screen allows you to specify the frequency for the sonde. Normally, these default values are fine. Click Next. The triggering profiles are used to determine how the software handles different events during the flight. The default values are fine. Click Next. Reconditioning heats up the humidity sensor to remove any surface contaminants. Normally, you want to recondition the sonde. Click Recond to force sonde reconditioning, and when it's completed, click Next. The GC or ground check is a calibration test. Click Perform GC. Now you'll read the pressure from the barometer on the wall, and when prompted, enter the value in the text box. You don't need to do anything with the temperature and humidity values, as they're automatically retrieved from the test set. Click Next. Now you have to check that the correction values in the calibration test are within acceptable limits. The pressure correction should be within 3 hectopascals. The temperature correction should be within 1 Celsius, and the humidity corrections should be within 5%. If the corrections are within limits, then click Next. If the corrections aren't within limits, click New GC and try again. If the corrections still aren't within limits, then you have to shut the hardware down, get a new radiosonde, and start over. At this point, we know the sonde is functioning properly and the calibrated values are within limits. The screen says it's ready for release, but the sonde is still operating on the power supply in the GC25 test set. At minute 0, 15 minutes before launch, connect the battery. Since the battery has to operate in temperatures of -70 Celsius, we want the battery to be as fresh as possible at release. Therefore, it shouldn't be connected any earlier than 15 minutes before release. Now our sonde is operating off the battery and the ground equipment is showing ready for sonde release. Confirm that the telemetry indicator shows a good signal. If necessary, select the radio tool and adjust the sonde frequency for peak signal. Ensure the PTU data are being received properly. Bend the sensor boom so it snaps into the holder. Visually inspect the sonde to confirm everything is secure. We're now ready for release. Now let's summarize the fundamental flight process associated with preparing the radiosonde. Open a new sonde and perform a visual inspection. Connect the sonde to the GC25 test set and then turn on the GC25 test set, the MW31 sounding receiver, and the computer. Start the sounding software and select New Sounding. Next, 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 next. Recondition, next. Perform ground check, enter the pressure value, next, next. Install the battery and tune in the sonde if necessary. The hardware is so reliable that the sonde preparation is almost always very straightforward. So once again, let's go through the different screens. You start the Digicor software and click New Sounding. The software connects to the radiosonde and starts reading calibration coefficients. The radiosonde properties screen allows you to select the type of wind calculations. The Edit Radiosonde Properties screen allows you to change the sonde frequency. Triggering Profiles determines how the software responds to events. Sonde Reconditioning heats up the humidity sensor to remove contaminants. GC Request allows you to perform a ground check. Then you enter the pressure value and click Next. You check the correction values to make sure they're within limits. The sonde is ready for release but is still operating off the test set power supply. Within 15 minutes of release, you connect the battery. Double check that the sonde is transmitting properly and then go outside for release. The radiosondes are very reliable and problems occur with the sonde preparation less than 1% of the time, but problems can occur and they require special procedures. First, the ground check humidity. The GC25 test chamber maintains a low humidity through the use of desiccant beads. As time goes on, those beads will absorb enough moisture that the chamber will no longer maintain 0% humidity for the ground check. When the radiosonde is in the GC25 chamber and the PTU status shows a humidity higher than 3%, the desiccant beads should be replaced. The desiccant chamber is located on the back side of the GC25. Pull out the desiccant chamber, turn the retainer screws holding the lid down and remove the lid. Fill the chamber with new desiccant, replace the lid and turn the retainer screws. Replace the chamber in the GC25. Rejected radiosondes. The radiosonde must be rejected if it fails the ground check. If the sonde has correction values outside of accepted limits, pressure correction greater than 3 hectopascals, temperature correction greater than 1 Celsius, or humidity corrections greater than 5%, click New GC and try again. If the correction values remain outside acceptable limits, click Command F2 and exit without saving. Shut down the MW31 sounding processor, the GC25 test set and the computer. Get a new sonde and start again. The radiosonde can also be rejected due to a sonde failure. During sonde preparation or while waiting to release, you may notice the sonde stops transmitting valid data, either pressure, temperature, or humidity. Select Radio View and check that you are locked into the correct frequency. If that doesn't help, then again, click Command F2, exit without saving, shut down the MW31, the GC25 and the computer, get a new sonde and start again. The radiosonde can also be rejected due to a GPS failure, due to no satellites or a hardware error. If the GPS sonde status is stuck at check telemetry, it could be a sonde failure. Similarly, if the GPS local status is stuck at check antenna cable, it could be a hardware problem. In both cases, reject the radiosonde and start over with a new sonde. If there's still no GPS data with the second radiosonde, it may be a problem unrelated to the sonde or ground equipment. In that case, we'll just do the flight and accept that we won't have wind data. To bypass wind calculations, restart again, and when you get to the radiosonde properties screen, select Wind Type None. This will allow the flight to proceed, but there won't be any wind calculations. Click Next and continue the normal sonde preparation. This completes upper air pre-flight preparations.